yes, Go modules at scale. If this, yeah, better. I like Go modules as well, at least since I discovered them a few months back. I didn't pick them up when they came out with 1.11, have to admit that. But yeah, interesting topic. First, small piece of introduction. Well, obviously, my name is Duco. I work as a software engineer at Improbable. You've seen us around here at Golang meetups before. We've done a few talks. Remember Apu, who did last time, about HTTP service. Hope you enjoyed that one if you were there. But mostly software engineers, so not necessarily on Golang, most of it, although I have been using it a lot. Most of all, I care about code quality. And again, I am not on the engineering velocity or code quality team. Sean here, he is. Just talk to him if you're interested in that. Anyway, I care about code quality, and hence this led me to examining our fairly large Go code base and how we might migrate it to make it a Go module, in a sense. We're going to start with an introduction. Obviously, for those who are not familiar with it, I'll try to give you kind of the basis of what it is, how you use it. Other people, you might just fall asleep, that's fine. I'll try to wake you up once you're done, and I'm done with that. Most of all, it's about migrations. As I said, our own code base internally, we're trying to see how we would potentially migrate that. That's why I sort of to attempted migrations. We haven't migrated yet, actually. But I'm going to do some live demos on existing open source projects. There's going to be references and some branches, things that you can check out. And most of all, I'm going to give you some real life examples that I've picked up on managing some open source projects and some of the issues that you actually might run out. So it doesn't mean that Go modules are broken in any kind of way. It's just that they show things in a different way. They make some things a little bit more explicit, which I personally actually like a lot. But it changes from what you had in the past, where you had a lot of third-party dependency management systems in Go. So for the quick introductions or reintroductions, what are Go modules? So as said, arrive with Go on 11 based on the Vigo experiment, for those who are familiar with it. And it's nowadays a native way of managing dependencies between products and your third-party things that you depend on. In the past, there were a lot of different systems, dep, go-dep, well, many, I'm not going to look at the full list, there's 8 well-knowns, and there's probably 20 or more less well-knowns. If you use one of those, please tell me, because maybe just for archaeology, it might be interesting in that sense. But nowadays, this was seen as a problem. And as usual with Go, the community, the Golang team, lets the community come up with various solutions and experiments. And then at some point, in a more or less consensual way, makes a decision and say, well, let's go with this kind of thing. This is how we're going to do it in the future, and make it part of standard Go tooling. This is what happened with the Vigo experiment. It got the blessing of the Golang team, and now it's basically becoming into mainstream. Some of the high-level consequences is everybody used to be familiar with GOPATH. Well, you can say bye-bye to it. Obviously, it will be supported as long as we're on the 1.x versions of Go. It probably will go away with 2x, but you will not be able to use it anymore, or at least need to use it anymore with when using Go modules as your dependency management. Vendoring as well, which has been a very controversial topic in the age of Go modules within the community. Some people, they just swear by it and only use it. I personally use it a lot. I'm not yet sure that I want to really kind of throw it away or not, but basically, it might work, but there's a lot of, yeah, but you have to pay attention to this or that. I just basically give you a link to a bit more of the official documentation of things that you have to look at. And last but not least, so it arrived in 1.11, it's opt-in with some kind of automated selections around it, nice automations, or you can force opt-in. It used to become standard in 1.13. Oh, that now has been pushed back to 1.14, so basically February next year, mostly because there's a lot of stabilization still going on, and they, I think, rightfully saw that the current state is good, but not good enough to make it kind of the default for everyone in that sense. So for the moment, nothing will break. You can just start using it, and even once it becomes basically the default, you can still opt out as long as we're on 1x. But yeah, something to keep in mind. So Go modules rely on versions. When you do versions, as usual, when you depend on which version of your dependency you're using, this is the way Go modules basically refer to versions. So different pieces in there in a string. Basically, when you have your third-party dependency, it relies on semantic versioning, or semver for people who are very intimate with it. I prefer not to be too much. You'll see something later about that basically in the state, because it can be a bit troublesome. Commit date, because you want ordering, basically which commits came after, and you can't just say that from a hash. And also, if it's not a release, then definitely you need to know when it was committed, and the commit hash, so basically you know at least which commit. So basically, if you take that last piece of the string, basically you can then just throw it in your Git or basically on the GitHub and find the commit yourself on the repository. In this particular case, it's a full string because obviously the last 2 bits are optional. You can just, if it's like a fully qualified released version, you can just do v111. That refers to the obvious tag in that repo, or it's not even just Git. It's manages plenty of it. Mercurial, SVN, Bazaar, anything kind of that has the same kind of VCS concepts. In this case, it's a pre-111 release because we have the v11 tag, but it's not just the tag. There's some data advanced it. So this was released after v110. It's basically follow-up, but it's not there yet as a stable release. And there are some other weird things you might see in the strings, but it should be quite fairly straightforward. You should just have skipped those. So Go modules defines dependencies in a go.mod file that you find at the top of everything that you do, basically your project in this case. And here you can see basically 2 random things that I created here of 2 different projects or 2 different modules in this case. And you say there's a require section in this case, which basically tells you which are your dependencies, at which versions. There are some other things, so replaces. This is for example used when you use forks or you want to do some local development. You can tell instead of taking the upstream or a specific version from upstream, you can basically use a fork or alternate version, or you just can actually use it to control the exact version that you're importing, because version selection is something that Go modules can be quite tricky about. They have a specific what we call minimal version selection. We can also exclude specific tags for dependencies, or I definitely do not want to use that because I know it's broken or it has a security issue. You can basically exclude it so that Go modules, the selection, the tooling knows not to use it when it does the dependency resolution, and plenty of things like that. So the interesting part here, though, is that in this case, the top one, the hello world, so this defines is basically the root of your import path. But basically also for your packages, and basically that's kind of you put when you have github.com/foo/bar package lib. Well, in this case, this will refer in this case to this package here, and the module in this case defined up here. Interesting thing though is the second one, that basically the lower one that the upper one depends on, also has this replace statement to select a specific version of a dependency. Replace and exclude statements only acts on the module that you're actually compiling. Not if there's any replace statements or exclude statements in the dependencies, they will not be used. Basically, you have full control over what is excluded and what is basically replaced from a fork perspective in your own module. Otherwise, people can do weird things. Maybe not as JavaScript weird things that we've seen earlier on, but still, you could become quite nasty. So obviously, very incomplete. I really encourage you to read the docs online, and there's plenty of them. I still discover pieces from specific sentences I find sometimes in a paragraph these days, even after a few months. But yeah, just read there's a very nice post on the wiki, the Golang wiki about it. But yeah, using modules for Rails, that's our turn. So you can have varying perspectives. The usual thing is either you have a project or you're starting a project nowadays. Now, I definitely recommend you start it as a Go module directly, very easy. Just a simple command, go.mod init. In this case, go.mod init also works on other projects that are already there that either don't have any dependency management or have already an existing dependency management like dep, godep, etc. It actually knows how to read the dependency specifications from those third-party systems and translate it into somewhat of an equivalent in Go modules. More on that later, you'll see. And afterwards, obviously, as I said, kind of maintaining an already modularized projects and the things that you might encounter when doing that. So fire off with the first one. I'm just going to give for a reference for people looking at the slides later on. But demo time. So this is a tool, go.mod, I actually created to how to handle Go modules in general and discover interesting things about them. In this case, I basically stripped out the Go module file. So basically, if you do an ls, there's code in there. There's, oh, wrong. Oops. Wrong one. Anyway, so stripped out the Go mod file. Basically, no dependency in this case. And because there's no dependency, I mean, there's no go.dep or go.dep.toml or any other kind of specifications, we can just do a go.mod init in this case. Initialization done. Well, doesn't do everything. For example, if I now can look at the go.mod file, you'll see that basically there's not much. There's actually no dependencies. It's basically just created a module file. There is some things that I would recommend you doing. For example, the go.mod tidy. This has the nice advantage of just making sure that all your dependencies that are actually in your code are correctly recorded in the file, that the versions have been checked and the right versions have been selected in this case. So in this case, you'll see it's going to do a lot of different things. It's a small project, not many dependencies, but you can actually see the, actually now you have actually some of those dependencies in there. So literally in this case. And it just builds in this case. So you can just do it here. And basically you have the binary hanging around, normally go.mod in this case. That's all it knows. In this, actually, this can do a little bit faster because obviously I reran this full, so it actually uses a cache, a local cache of all those dependencies. In this case, it just selected out of the cache because the versions were already there. Otherwise, you would see a list of things fetching, downloading, checking versions and whatnot. But yeah, that's easy. So this is literally the usual experience, actually the exact experience that I think Paul demoed last summer when he just talked about introducing Go modules, like just when they are about to go live. And it's a very pleasant experience. Like if your project is not big, it doesn't have a multi-year history of weird dependency management or other quirky things done with forks, it will just be working that way. So yeah, and just simple run on it, and we're ready to roll. That's about it. Job done. I can go home. We can all get to the pub, get some drinks. Unfortunately, not. Migrating a project with existing dependency management. So actually, I thought, well, I attempted to do our internal tool, but obviously there are things about some code you can't share, but also because, well, it didn't work for reasons I'll detail. I choose to go with another well-known open source project in Go that actually had active dependency management, in this case, Kubernetes. And I went basically to the point where they're about to introduce Go modules. To be clear, this was one person working on it, but it took over a month. And to be fair, if you really look at it, they were not in a very nasty case. It's just, well, dependency management has always been complex. Go modules doesn't change that. It's more that it makes it more explicit, and you have to think about things. Otherwise, it will just break. Otherwise, in other situations, older systems, things looked like they might work, but they actually didn't, or they break in unpredictable ways. Again, Go modules make it a little bit more explicit, so you can actually work with that. So in this case, there is indeed no Go mod in here. That's it. They do have their normal dependencies. There's a whole Go deps specification, as you can see in the top corner. But let's try what we did, just the Go mod in it, see what happens. So obviously, it recognizes some of the information. It actually says that it's now translating the existing dependency specifications from this known third-party system, and it's initializing its own Go mod file based on that. So actually now we can see it. This is not actually going to contain quite a lot because we already had preceded the requirements that were in there from the other system. And you can see already a lot of dependencies in here. But does it work? That's the question. So let's say just one of the internal tools in this case. Let's just say the CLI check. Can we build it? Well, now you can see it starts finding. So this is just finding. It's not trying to download everything. I luckily pre-cached it. But it can't find a module or something, or it can't find dependency. So what is going on here in many cases is that obviously for those who are familiar with the Kubernetes project, they have staging areas, there's things hanging around and dependencies within the repository that kind of look like different sub-projects that communicate with each other. So it doesn't really work well. So you have to specify some replace statements, as I suggested before, because actually you're referring code that's in a different module, but within the same repository, because something I said didn't say before, a same Git repository or any other VCS repository can contain multiple modules in different subfolders, and they can actually work and depend on each other in interesting ways. So I'm not going to solve this right away here. Actually, I jumped to a place where this was actually solved. So actually, I'm already kind of preceded it. And actually, they use a tool to generate it. But what you can see here is that they actually have Actually, I stripped away, this is not the official thing that I entirely checked in, but you see, these are all things. So in this case, if anybody's looking for a package which imports paths, starts with KDS.io API, actually don't go looking for something on the web or something, a repository, remote repository. You should look at a local file, which actually you can find in the subfolder, staging, source, etc. And this is basically how you define on those internal modules that are local to the repository yourself and that should be checked out at the same commit. This is what, so you can also where you see that those replace statements, it's not just to a different repository, it can also be just a file URL. This is what I said, if you want to co-develop and test something while you're debugging, working with two separate modules that depend on each other, you can do that as well. It's not that you first have to change one, uploaded one, then basically check in that, and in your other model reference, that new commit that you just created in this fork of yours, you can actually do it on disk in this sense. So does this compile in the same way? Well, let's hope so. Basically, go building, see if it doesn't fetch, looks like everything's going fine. And actually, we built it in this case. So this case, it was just a piece of replacing because of the particular structure that the Kubernetes project uses for their repository and their code management. But again, I also said that this is not exactly how their usual go.mod works. So they like pinning their dependencies, and pinning, it's not just, I give you some constraints, as for example, Dep worked in the past with their SAT solver that actually give some constraints, and it would just find the best versions you could use, and then you might want to upgrade it. No, they like to know exactly which specific version every dependency they're using, and also know when they're updating it, in the sense. So literally, if you look nowadays in the Kubernetes, I'm not even going to show it, but basically, every single dependency that they have in those require statements of things that you depend on has a corresponding replace that basically replaces it with itself, but at a specific version, because replaces go outside of the normal version selection system that Go modules rely on, which I'm going to take a little bit more. So Go modules basically uses minimal version selection. So you specify you depend on projects A, B, and C at specific versions. Your dependencies might rely on some of the same indirect dependencies at specific versions. For each of those dependencies, you select the highest common denominator among all your direct and indirect dependency paths. And that basically creates some interesting challenges. The thing is, it's in linear complexity, not a SAT solver, which probably could take ages if your project becomes very big. We use Dep internally, and it becomes pretty expensive. So this is actually a nice improvement in that sense. But again, those replace statements, they basically say to Go module system, ignore any of your minimal version selection, you just use the hash I give you. So again, you are in full control of your build, you can just pin whatever version you want and use it. But they do try to use the same version as the minimum version selection actually corrects and actually recommends you to use. But yeah, demo time. What happened, again, pretty smooth transition Go mode, and it's just had to account for some of the particularities of this particular project. But again, this is a fairly large project. So if you also have a fairly large project that doesn't do weird things from a dependency perspective or uses of specific forks, it should be relatively straightforward. But there are issues. And now I'm just not talking about Kubernetes, I'm talking about my personal experience at Improbable or in some other cases, where the things that are somewhat implicit, and to my idea, not explicit enough in Go modules in the current way it's been documented, is that everybody is required to use Semver. Because obviously, if you make breaking changes between patches or between minors, then minor version selection is, well, it's just a patch version. You can upgrade, it's fine. But no, that might just break the whole chain down the road. And that actually becomes pretty tricky, especially if you mix set forks in there as well, and all the minimum version selection goes with it. I just wanted to call it out because literally it's been pretty painful for not just for me, but many engineers at Improbable there's been some spec changes in protobuf, but basically in 3 they removed the unknown fields, and then due to the kind of hellish reaction from the community, they reintroduced them, which was nice, but it was done between minors, and it's fine. It still respects Semver because, well, it's a spec change, and our project definition says that a spec change doesn't mean that we're making an actual breaking change. That's fair, But as coders, that doesn't matter for us. Like, our things break because of this. And this is literally causing months of engineering work for us, and for many others, I guess, in the past, or currently still. Again, fun with forks that have broken with their upstream. So your fork, because somebody's trying to do something nice and add something because the upstream either is not reacting or they just want to hack away. That's nice. They don't even break compatibility. Some versions still respect it. But 2 years later, the fork has evolved in a different way and might have kind of the same version, but it's not compatible anymore with the upstream. And at that point, actually, what it should become its own module in module land. You shouldn't just be re-implementing the same module, because forks re-implement the same module just on a different repository. No, you should become it because you need to care that you are actually compatible with your upstream. Otherwise, those replace statements, again, it's just going to become hell for a lot of your users downstream. Also, obviously, if you don't make any stable releases, well, you're supposed to be evergreen, but a lot of people just develop without having any stable releases, and breaking changes happen from time to time because, yeah, we're not stable. Again, that can be quite painful. I have luckily not yet run into many issues with this, but I can foresee as the module ecosystem grows over time that this can become quite a big problem for many people, just because things start breaking around. And especially, you need to be very careful about what you depend on and what your dependencies depend on, etc., which is obviously kind of an issue. Which brings me to the last piece, about the maintenance of a modularized project. And that's where I'm going to use a little bit more of kind of self-selling about the tool go.mod I just talked to you about that I wrote, because it actually allows you to inspect this dependency graph and all the weird things that can happen with it in that sense. I'm using a last project, which I'm a contributor, Matterbridge. Very cool project. If you're doing into chat apps or anything, it basically just bridges any, well, not any, but many chat protocols, like 20 different of them. So you can actually sync up chat rooms between Slack, Discord, even I was talking on Facebook actually at the moment. It's a very cool project. I recommend you check it out. Not because I developed it, because I'm definitely not the person who started it. And the person doing it is really great. So in this case, actually an interesting thing is that obviously good product uses CI. And what we noticed in this case, actually, if I look at this, just checking out the right here. In this case, we noticed something interesting happening, which was a PR was raised. In this case, particularly the dependency, we were relying on some fork of something, and then we used another fork or another upstream. PR went green, everything built. Okay, just merge it. Coming back a little bit later to it, this is not maybe the same commit, but the same code, just basically you're rebasing your commit when it was merged. It doesn't build. Why? So I checked this commit over here. And if you just want to clean up your dependencies, make sure everything's right, you run it, it just tests something, can't find the revision. Anybody knows what happened here? Any ideas? Nope, nobody rebased. Yes, somebody rewrote history of force push. Very cool. Well, obviously you could say that we shouldn't depend on the latest commit and just use stable releases. But again, some projects don't use stable releases. And we just want to use the bleeding edge because, well, that's all the fixes that we need and that we actually push that there ourselves. So please don't force push. Or if you do it, just do it within the next 5 minutes after pushing to master. Otherwise, people will have issues. Please don't do it. It's really bad. So in this case, if you do the fix, well, what happens? So actually, in this case, I did do the fix in my separate branch. In this case, if you have a look at it, it basically was the last other one. Basically, I had to reference a different commit in this case and see if it builds. Or again, obviously, mod tidy dependency resolution works. Now let's build. Does it work? I'm taking bets. Yes, no. It's trying to resolve in this case. So actually, it will throw an error. Because, again, there was either some, well, here, the code changed in this case. So what do? Well, you can't do much at this point. Basically, we stripped out this dependency because basically they broke with their upstream in this case, and we need to rebase our code and do some weird changes in this case. So to finish off in this case, how would you see this? So obviously they were basically what they were doing, mostly importantly, they were doing their own, in this case, replace that we didn't implement in this case. So in this case, what I would do, the tool that I use, this is actually a tool that tells you what your indirect dependencies replace themselves in their own Go modules, and whether they're matched with what you're doing. So we can see that here's some stuff that we're doing as well, but this one you have over here is basically really broken in this case, because basically this dependency of us is replacing something that we depend on as well, but we don't have the same replacement in here in that sense. Not nice. I don't know if anybody else has encountered this kind of things, because I believe definitely some of the people here are doing some things with modules, but just give me your reaction if you have any. This is a reveal. Last piece, and I was talking about the most important piece, which is your dependency graph. So you can actually trace those in this case. I'm doing some here. Nope. So basically create dependency graph, and I use dot in this case to trace it. So if I do here the open command, you actually can trace your dependency graph. You can annotate it with this tool, as you can see which versions people depend on, how these things are, how actually the minimum version selection is, because you see, well, this module is dependent on by these different people, and people have different version requirements on it. Is it forked? Is it replaced? Those kind of things. You can even see whether some people actually prevent you from using the minimal version selection to downgrade to a specific version, whether you can depend on it or not. So yeah, this is some of the cool things to do. Last but not least, there's also a go.mod analyze command. And this actually gives you some statistics about your dependencies, like how old are they? Are you just relying on things that are 5 years old? Or is it you're on the cutting edge? In this case, also kind of some other interesting statistics around it. But yeah, this is basically, so maintaining a model as project, some things going on. I had to rush a little bit through the fix here, but here are all the references that if you want to look at the code yourself in some ways, and also the discussion we had with it. So like I said, we had a dependency that rewrote history. Please don't rewrite history. I cannot stress it enough. Somebody used actually broken go.mod because they used the replace, and a replace actually makes sure that it doesn't really look at the version that you are doing in the require, but other people only use those requires, not the replaces. And then the conflicting use between the fork versus upstream in this case. So to summarize, because I've been talking a lot here, migration should not be underestimated. I've learned it myself from many different projects. Depending on the size, it might take 10 seconds, might take 2 months or more. Most of all, importantly, do learn the interactions, because your because it's a native thing, all your usual Go tools and Go commands, they interact with your go.mod file. The go get basically knows how to deal with this. All those things. There's also a lot of separate commands that actually manage. You can do your editing of your go.mod, not just by doing it manually with Vim or any other editor. You can also do it via the command line. You can use replace statements, especially when you're doing migrations. Quite important. Because you need, sometimes if you have those very complex dependencies, you need to be able to select specific versions. Otherwise, and maybe otherwise fix your dependencies, but still, if you want to do the migration, use those replace statements. They're very useful in that manner, and they're intended to be used in that way. Lesson 2, you have to really be more explicit of how you manage dependencies. Those hacky upgrades, again, you can do them via those replace statements, but I firmly believe they will start biting you later on. They will just, at some point, it will just become untenable, and you need to be actively maintaining it and upgrading it, keeping it up to date with upstream. Semantic version, as I said, is compulsory, so basically, please respect that. And if you're not doing it, well, let's hope that the community moderation of it is kind of getting to you, because you do need to make sure that you are not breaking your users or even indirect dependencies in that sort. Last but not least, it is actually a pretty nice system. Like if you really use it on a day-to-day basis, it's basically native across the entire language, across the entire ecosystem. It's very early days. Obviously, it's still opt-in, but you see more and more of the more well-known libraries opting into it and using it. And I firmly believe that will actually become even nicer and easier to use because it knows how to deal with non-modularized projects, but it works way better if the things that you depend on are actually modularized themselves. It's an explicit determining dependency graph as well. I think that was last time Paul gave it a very good talk about it. And there's a lot of tooling around it that you should use, explore, or build your own, just if there's any lack, something that you can't do with what you have. That's about it for me. There's some resources here. Like I said, the go.mod tool, the wiki entry is really useful. If you're really more into the technical selection of version selection, you can actually have a look at it as well. Linked it here. And yes, that's it for me. Small talk, Improv was hiring, so do drop us a line or just come talk to me. Happy to help you out with that.
Time for 1 or 2 questions. Anyone?
1 second.
Thanks for the talk. I can see how a big over here.
Yeah, fine.
I can see how a big complex project can be
Yeah.
quite difficult, and the challenges involved in migrating to using modules. But I write code that's very much at the beginner end of the spectrum. So I've got a question that sort of relates to that.
Yeah.
I used to write packages.
Yep.
I used to write little simple command line utilities, which were package main, but I didn't really sort of classify them as packages. What is a module? Do I just use modules instead of packages? That doesn't feel right because you can have multiple packages inside a module. Yeah. Do applications become modules? I'm stuck at the simple end of the spectrum, not the sort of complex stuff.
No, I actually think that is a very valid question, both for the small end of the spectrum, beginning end of the spectrum, or the very like complexer end. And I would even say there are different schools about it, or I mean, it's too early to talk about thought schools about it in the sense that it's so early. I remember talking, it was actually given here at Monzo, last time we were at Monzo, was something about command line tooling and how you structure your packages in there. I think it's going to be the same. There's going to be different ways of doing it that depends on what you subscribe to and what your goal is. Like I said, the Kubernetes project has actually a lot of small submodules for some of the functionalities, but then still, even the core one is pretty big. If you have a monorepo, you can basically make it an entire module itself. Like I wouldn't say that you need to have, there's a specific size you have to hit for a module. It's more about what it aims to do and how the relationship is between the code. Like if you want to have small pieces that you can release regularly and that actually are loosely coupled just by nice API boundaries, then you can make multiple modules. If things are a little bit more closely linked, you have some core libraries that basically are tied in everywhere and that kind of permeate your whole code base, you might want to go with an entire module. But again, I would not say I'm the authority on that, definitely not. But yeah, I think it's more what makes most sense. And talk to the people who are using or depending on your stuff. Like, does it make sense for them?
So watch this space and see what happens.
Yeah, it's early days. The Go module ecosystem is obviously very, very small for now, but well, we just can see and watch in an exciting way how it grows.
Thank you.
Yeah. Anything else?
Thank you for the talk again. Did you have any circular dependencies?
Yeah, circular dependencies between things. Actually, that's authorized. It's very possible. You can depend on yourself at a different version. But that's, if you have any specific questions about that?
Indeed, but what if the circular dependency is depending on a different version?
Yes, well, actually, that's a pretty standard recommended pattern. So if you know that you're going towards a new major release of your package or your software, one thing is basically, well, I didn't even go into how majors are being dealt with in the age of modules, which is quite peculiar and an interesting pattern as well. I definitely recommend Paul's talk from last year about it. Just watch it on the YouTube channel. But mostly, you could literally, if you don't start directly about, it's more an API change, but not a functional change, you can literally create a subdirectory that implements a new major with the changed and the broken, like API change and the broken changes. And that is basically a wrapper around the rest of your code, which is your old version. And then slowly over time, you migrate things over and you start making real implementation changes in this new major wrapping, replacing the wrappers with actual new underlying implementations. That is actually quite normal pattern that I think we'll see emerge quite frequently.
Yeah. Where I was going with this question is when you're trying to remove something
Mm.
and you have a circular dependency, it will be really hard to figure out how to. go.mod, your package, will be able to help this?
I'm not entirely sure what the exact issue is that you're referring to, like what you're trying to remove here. Are you trying to remove your dependency on a specific module?
Yep.
So if you are like modules, like you can depend on the same module at different majors in the same package. So if you depend on both, basically you can eliminate them separately and it will work. But yeah.
Thank you.
That's it. Oh. Yep. Yeah, lost.
Thank you very much. I have a question. When you had an issue with the rewrite of the history with the force push,
Yes.
does not the GOSAM is here to tell you, oh, it's completely different, I don't have the same, so it's definitely different?
That would work if you have everything already checked out, like it's in your cache. But if you are cloning that repository and building it for the first time, like it will try to look for a hash that doesn't exist, and that won't work. You could theoretically solve it by a go get on it, but then again, like you need to make that change because that will influence kind of your go mod, and then basically make a PR or push that upstream again so it's fixed. And that's what was done here in actually.
Yeah, I think Go is trying to solve this issue by creating a read repository where you could check all these
Yes,
GOSAM.
I didn't even mention that. Like I said, it was talking about tooling and community tooling, like the Go, the module proxy server in this case, as well as authenticated proxies. So things are signed, so you know when you're downloading some source code. You actually have an authoritative server that actually just tells, yes, your signature is correct, the SHA corresponds, this is the right content you're downloading, you don't have any injected stuff. But that might depend on how it's set up. Like it might help you, otherwise it might not. Because if your rewrite is not like sometime after you push it, like after the original commit, but not that long, it might not have been picked up in any cache server. Like that's very unpredictable territory. Again, that's why I'm saying just do not rewrite history in such cases unless you know very well what you're doing and you're warning your users in that sense. It's just easier just to, if you have to revert something, just put another commit on top of it so you don't break the old one.
Okay, thank you very much.
Yeah. I don't know if there's time left. Oh.
Yeah. Thanks, Duco. With the GOPATH, it's quite obvious where the packages you download live. Where do they live with modules?
They live in the cache. So there is currently there's kind of the default Go path, which is default to your home directory /go that's being created. There's actually a cache directory in there that is populated with everything that's being downloaded. But again, because like the module depends, like it allows deterministic and well-known dependency in this case, it doesn't go randomly looking based on a Go path somewhere. It knows exactly in the cache what the path is you're looking for, like what the module name is, what version you're looking for. It has local Git checkouts or VCS checkouts of your things and knows how to reference them in that case. So you can even look into, I didn't do it, but in VS Code or any other editor, when you click through dependencies to your in a Go module to those third-party dependencies, you can actually see the file you're opening is in that cache.
But the cache is shared between modules that are developing locally.
Yes, because the cache is obviously it's immutable in that sense. You're not going to change. You're not going to edit files in there. You can do that, but and all bets are off. Like, just don't. They're easier. But like I said, if there's one of the dependencies you need to debug, as I said, then you make your own checkout of that same repository somewhere as you would do for any project that you modify. And then you use a temporary replace statement in your own Go mod to point, instead of to your cache, actually use the one that's on disk. And then basically you can start modifying and things around, because at that point, it doesn't check integrity or anything else. It doesn't try to fetch things, and basically just builds from the source that you actually also maybe have modified in your third-party dependency.
Awesome.
Sorry, just for the people who are remote on the YouTube, you might want to.
So I think that the dependencies are firstly read-only. They are under GOPATH, PKG, and then mod, and they're all read-only. And
Yes.
if you actually sudo change it to writable, and change it, and next time you run some go command, it'll say it's changed.
Yes, because there are some checksums that are being done on it. I'm just saying, so it's like beyond just not doing it, it will start throwing errors, but just in case, just don't. Like I said, if you...
Yeah,
in
I mean,
that
yeah,
case,
One tool to use is actually Roger Pepe's Go Hack,
yeah,
which
exactly.
helps with quickly editing a module.
Yeah.
Any
I
more
should have
questions?
put a list up of all the nice
Yeah, yeah,
tools that are out there.
We're done, Antonio.
Cool.
Thank you very much.
Great. Thank you very much.